So far in this unit, we have focused on solving non-right triangles and finding their area using the law of sines and law of cosines. In this video, we're going to be finding area of triangles using a formula that comes from the law of cosines, and then we're going to look at one application problem, and that will wrap up the unit. In a previous video, the area formula that we learned was 1/2 AB sine of C. And remember, all of these variables might switch around a little bit, but this angle will always be the opposite letter of these two side lengths. But this formula does rely on you knowing two sides and an angle. And in some problems, like number 1, we have all three side lengths. And that's why we're going to use this Heron's area formula. And it's just named after the person that came up with it. So if we're going to use this formula to find the area, we're going to have to take the square root of all of this stuff. And there's this letter S in here. So A, B, and C come from the side lengths of the triangle, but this letter S comes from this other little side formula. So S is just this new variable that comes into play, and all you do to get it is you just add the three side lengths up and then divide by 2. Once you have that S value, then you can plug that into this formula along with the three side lengths. So let's dive into number 1. I'll start by finding that S value, which means I have to add the three side lengths up and then divide by 2. And doing that should get you 18. And then after that, to find the area, you just have to plug in that S value along with A, B, and C into that area formula. And again, at this point, that's just a big mess that you can type into your calculator. And it actually comes out pretty nice. It turns out to be 54 units squared. Again, I'm just adding that units squared because we are talking about an area. And that's all there is to it using this formula. So let's try that again with number 2. Again, we have to start by finding that S value, which means I'm just going to add the three sides up and then divide by 2. And that turns out to be 89.7. So then just fill in that S value along with the three given sides. And since two of the side lengths are the same, I decided to just write that factor once and then just square it. So again, at this point it's just calculator work, but you should get 1350.2. So using these area formulas are pretty easy. Really the only hard part is just determining which one you should use, and it just comes down to what information you're given. If you have two sides and an angle between them, then obviously use this area formula that came from the law of sines. If you have all three side lengths, then you'd want to use this formula. So we're just going to take a look at one more application problem, and that'll be it. So this problem says a plane flies 810 miles from Franklin to Centerville with a bearing of 75 degrees. Then it flies 648 miles from Centerville to Rosemount with a bearing of 32 degrees. Draw a figure that visually represents the problem and find the straight line distance and bearing from Franklin to Rosemount. Alright, now before we get too far into this problem, there's a few things I want to point out about this diagram. So they told us that these bearing angles are 75 degrees and 32 degrees, but you notice that there's no north and east, or there's no letters on either side of the angle. So these bearings aren't given in the normal format, but we're just measuring them like we normally would on the unit circle. So this would be 0 degrees, and then here's my 75 degree bearing angle. Same thing at Centerville, this would be my new 0 degrees, and this would be 32 degrees. The other thing you should notice is that since we're talking about this application problem under the law of cosines, remember that the law of cosines works for side, 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 and side, angle, side. So we have to be given one of these two cases in order to work with law of cosines. And obviously we weren't given side, 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 because the thing we're trying to figure out is one of the sides. So we must have the side, angle, side case. And looking at the diagram currently, I know that this side is 810 miles and this side is 648 miles, so I must know this angle in between, or I'm supposed to know the angle in between. Well, I know this much of it is 32, but let's see if I can figure out this much of it. So probably the easiest way of figuring this angle out is if you remember that these two angles are considered consecutive interior angles, and that's because we have these two 0 degree lines that are parallel lines, and then this is kind of a transversal cutting between them. And these two angles add up to 180 degrees. And that tells me that this would have to be 105 degrees up here, because 105 plus 175 is 180. Now, honestly, I forget about those consecutive interior angles quite frequently, but you could also think of it this way. So thinking back to having that transversal between these two parallel lines, I'm just going to extend this one out a little bit, and then this 75 degree angle would be an alternate interior angle with this 75 degree angle. So this is also 75 degrees, and then you could see that, well, if this is a straight line, 75 plus what equals 180? These two together must equal 180. So obviously you get the same thing, it's just kind of one extra step. But the important thing to know is that we now have this entire angle, so 105 degrees plus this 32 degrees. And I'm just going to call this angle C for Centerville. So we now know that angle C is 137 degrees. Again, that's just 105 plus 32. So now I really do know side, angle, side, which means I can use the law of cosines to figure out the length of this last side here. Now let's just call that side C, since it's opposite from angle C, and then I'm going to set up the law of cosine. So if that's what I'm solving for, I'm going to say C squared equals, and then remember you just add the other two side lengths up squared, so that would be like 810 squared plus 648 squared, and then you subtract those two side lengths with a 2 in front of it, so minus 2 times 810 times 648, and then cosine of the angle, and that angle has to match up with this letter, so angle C, and we just found that was 137 degrees, so cosine of 137. So this is just a big mess that you can type into your calculator, and then take the square root of it, and you should get that C is 1,357.85 miles. And we did end up having to round this value, and I just picked to go to the second decimal place just because we're talking about miles, and that seemed like a decent level of accuracy. But that wraps up this unit on finding the area and solving non-right triangles using law of sines and law of cosines.